Ladies and gentlemen, a very good morning. May I have your attention, please? In around 5 minutes from now, we will begin with session 2 on this second day of the 2022 Korea Maritime Week. So please take your seats now. We will soon begin. And the session will be moderated in English and simultaneous interpretation will be provided. You'll find the interpretation receivers on the table. For those who need interpretation from English to Korean, it's channel 1, and channel 2 is for Korean into English. Please take note of that. And I would also like you to please turn off your cell phones or put them into silent mode. Thank you very much, and I'll see you in a bit. Good morning, ladies and gentlemen. Welcome to the second day of the 2022 Korea Maritime Week and for session 2. My name is Hoa Kwon and it's my pleasure to be your MC again on the second day. I think I recognize some faces from yesterday. 네, 어제에 이어서 오늘 행사의 진행을 맡은 저는 아나운서 권소아입니다. 여러분 반갑습니다. 네, 감사합니다. 네, 지금부터는 영어로 쭉 진행을 하도록 하겠습니다. 통역이 필요하신 분들은 참고하시기 바라겠습니다. All right, session 2, the International Green Shipping Forum will deal with issues and prospects related to the marine environment, such as ship equilibrium water and hull attachments. So without further ado, let's get started. Our first speaker is Arsenio Dominguez, Director of MED of the International Maritime Organization, whose presentation will be on the maritime environment development at IMO. Director Dominguez will also lead the panel discussion later on. And let's now welcome him onto the stage as he is already getting up onto the podium with a big round of applause.
Good morning, everybody. First, thank you very much to the Ministry and the organizers for the invitation to this event and for the great hospitality. We had a very good day yesterday, and of course, we followed very interesting discussions, not only in the morning, but in the afternoon in relation to the emissions of greenhouse gases from international shipping. Now, I set myself a couple of tasks this morning. The first one, and I need your help with that, is if I'm speaking too fast for the interpreters, please let me know. Somebody needs to wave at me. Where I come from, we speak really fast. It's just the way we are. So I'll try to slow down. The second one is the first presentation in the morning, so I need to find a way to you engage and also to keep you awake. I know that there's a lot been going on this week. The third one is somehow make this presentation interesting without going into the topics that the distinguished panelists following me are then going to deal in more detail. So somehow I need to make this interesting without trespassing the other side. I'll get my own back later on when I'm moderating and I get to ask the questions that they have no idea where they're coming from. Well, we'll see how it goes. So there's a lot that we do at IMO in the Marine Environmental Division through, in particular, the Marine Environmental Protection Committee. Now, if you look normally at a ship, you see all the different areas where the pollution can come from. In the last few years, of course, the main topic has been GHG, together with other air pollutants like SOx, NOx, and particulate matter. And we're even looking very closely into black carbon. I know I said that I was not going to touch upon it, and I'm not going to go into details of black carbon, but it's still one of those areas and pollutants that we are looking very closely at. Yesterday, you had a whole day of discussions, particularly focused on this, so it's a bit of a novelty for me now not having to focus on that specific topic. Instead, we're going to look into two other topics that are just as relevant and as important for the organization. Now, you see how we work on different parts of the ship when it comes to pollution. Ballast water and biofouling are the main ones that we're going to touch upon later. However, we still have oil spills. We have to be prepared for that. And in recovery, how delicate the marine environment is. The loss of cargo, that's another important aspect. And of course, it comes together related with the safety. Sewage and garbage. Plastic is a big topic right now. We already regulate plastic through MARPOL Annex 4, but of course, there's still a lot more that we can do. Sorry, I said 4 is fine. There's a lot more that we can do. And earlier this year, the United Nations Environment Assembly agreed on a global instrument to tackle plastic pollution. That's an area where we at IMO has a lot of experience, and we are going to participate very actively in that development. Not just to share the information and the knowledge and experience that we already have, but also to see if there is anything else that we need to tackle within the regulatory framework. MARPOL Convention, of course, is the umbrella convention when it comes to protection of the marine environment. It's going to turn 50 next year. It's a big year for the convention, for the IMO. we're going to focus on how we're going to, not just to celebrate everything that has been achieved through the adoption of the Marpol Convention, but where are we going with it? What is going to be the next, let's say, 50 years of Marpol? Now, the most important part, and the reason why I like showing this slide, is the bottom row, and it's about the tonnage of the world that already meets the requirements of the Marpol Convention. So not just the numbers of the parties, it's actually the tonnage that is covered, how almost, and in all of them, over 90% of the tonnage, it's already fulfilling its requirements in order to protect the environment. Now, as I said earlier, there are two main topics that we're going to discuss today, and of course, they are directly related to invasive aquatic species. This is one of the great threats that we have around the world, ecologically. We have already, for many years, seen how invasive species from remote areas in Asia have actually made it all the way to the Great Lakes in the United States and Canada. And that's just demonstrates how difficult to control this is. Now, of course, it has not just the damage on biodiversity or the environment, but actually has a negative effect on humans as well. In Peru, several big outbreaks of cholera have been associated to invasive species. So this is not just to protect the environment. We have to realize that by protecting the environment, we're also protecting ourselves. Now, I'm going to say this, and it's going to be easier when you follow the next of the discussions later. But the eradication of aquatic invasive species is nearly impossible. I mean, it has started already. But there's still a lot that we can do to control, to minimize it, and probably stop it from happening again. And these are the focus, the objectives that we have within the organizations. We can be quite ambitious when we try to do the right thing. And in this instance is, what else can we do to stop what it's been happening? And now that we know the negative effects that it's having around the world. Now, you heard yesterday, and you will continue to hear this. This is shipping around the world. You experienced it during the pandemic. Shipping didn't stop. It's necessary to trade. It's necessary for all of us to carry on. It was necessary for countries to survive during a very difficult time. So it demonstrated how important we are. And it's not expected to slow down. If anything, it's going to grow. And what's going to happen is that the challenge will continue to be with us and how we're going to stop these invasive species for causing even more damage. Now, the main topics that we're talking today that are the focus on the IMO right now in dealing with invasive species. Ballast Water Management Convention, you all have heard about it. It's been with us since 2004. Before 2004, it was in the form of guidelines, non-mandatory measures within the organization. So don't worry, I'm not going to give you a lecture into what the convention is all about. I'm pretty sure that after nearly 20 years, we will be very familiar with the work of the convention. And the biofouling guidelines, which we developed in 2010, and they're not mandatory right now. We're still working on their implementation, gathering information, and we started the process of its revision. Because we need to look into the next step for this instrument. Now let's start with the Ballast Water Management Convention. As I said, 2004, so it's been with us for a long time. It hasn't been an easy ride. We all have accepted it, but we have actually faced the challenges and we continue to do so. Right now, over 90%, this is 92.40% of the world tonnage is covered by the convention. That's a positive step. It means that we can still do a little bit more when it comes to the protection of the environment through further ratifications of this convention. And over 70 type-approved ballast water management systems are already been gone through the process within the organization. Here, a small parenthesis, thank you very much. The Republic of Korea has been one of the leading countries in this aspect. From the development, the implementation, providing information and experience, and also suggestions into what else needs to be done in order to improve this, which of course led us to the adoption of the code in 2019 to actually strengthen the implementation and the process for the approval of the ballast water management system. Now, what happens here is a simple and then just a very general panoramic view of the convention and the main parts of the implementation. The ballast water exchange, which is the D1 standard, as everybody will refer to it, the ballast water discharge, which is the D2 standard. They all have the necessary prescriptions into what needs to be done. On the exchange, of course, it's at least 95% of the volume that needs to be exchanged. And the discharge, this is a permanent standard where the ballast water must contain a minimum for fewer viable organisms specified within the convention. So we have a limit on what can actually be discharged. What this graphic shows here is the different information. And I'm going to say another thing here. I'm very sorry that you won't find these presentations on the booklet, and I apologize already to the organizers. Main reason why, and I'm not blaming anyone else here, is because I was going to moderate later, and because there are presentations that follow suit, I wanted to receive all the other information in order not to trespass or then make my colleagues later on to repeat what I've already said. So this is the reason why it's not there. Sincere apologies. Now, 2017 and 2019 key years here for the ballast water exchange and the ballast water discharge. Now, the biggest one is 2024 because that's when we move into ballast water discharge. And this is where we're already gathering all the necessary information, and it's called the experience building phase. It is going to look into what else we need to do into the convention. And this is where probably the real problems will start. As we get close to 2024 and we start receiving and continue to receive information of ballast water management systems probably not performing in the way that they were expected, or the different challenges for the ships to actually meet their requirements. Now, a couple of more things about the convention, and is the ballast water management plan and the record book. Now, these are essential because these actually provide the compliance with the convention. These are aspects that are going to be inspected by port state control officers. And again, they will also provide essential information for the review of the convention. Now, this is the experience building phase. I promise my colleague that I'm not going to go into it in detail because he will actually deal with that later on. He's been, and this is Colin, he's going to come over later. He's been actually one of the leaders in the preparation and the development of the experience building phase. And of course, that has moved right now into the convention review plan. Key areas is that we are right now on track, as we decided in 2017, on the revision of the convention. And what we're doing is just working together. And at the same time, not doing a piecemeal work that may end up changing the requirements in the very short period of time and affecting the ship owner's decisions. So we're gathering all the information and we're going to do one full review. In the meantime, we're still working on several aspects to facilitate the harmonized implementation of the conventions. We had issued specific interpretations of the convention, particularly on the mandatory commissioning testing of individual ballast water management systems. We have moved into the development of the protocols for the compliance of the monitoring devices, the application of the convention to specific ship types, recognizing their challenges, as well as the areas where they operate. Some areas that are quite sensitive, and we're still getting a lot of information of what to do, is, for example, how do we apply the treated sewage and grey water in ballast water management? Is it through the MARPOL Convention? Is it through the Ballast Water Management Convention? We need to provide additional clarification in this respect. Ships operating in ports with challenging water, what do? The ballast water management systems don't seem to operate properly when they face this. Now, we haven't forgotten about this. It's just that during the COVID pandemic, we had some limitations in how much work we could actually do. So we needed to focus our attention in aspects like the GHG emissions for obvious reasons. Doesn't mean that we didn't follow through with these aspects, but we couldn't devote enough time because we didn't have it. So what we did was we kept the momentum, we kept the exchange of information, it kept arriving to the organization, and now that we're moving back to in-person meetings at the organization from December this year, at least at the MEPC, we're going to be able to establish the working groups that deals with all these aspects in detail with a longer period of time. Because so far right now, at the last MEPC in June, we gave them 3 hours a day to deal with several issues that have been accumulated for 2 to 3 years. So the progress will come. We just need a little bit of understanding and patience in this respect. Now, let's move to the biofouling guidelines. Because of course, this is about the accumulation of invasive species in the ship's hull. And it's a major pathway to transfer microorganisms that are not very welcome in other parts of the world. They do change the ecosystems very drastically. And you have the micro ones and the macro ones, the ones that just start building up until they grow into animals that actually stick to the ship and they make the hull the living environment. There are many areas that are susceptible and not of easy access. Remember that this is mostly on the water, so we also have to work in how the operation can take place to clean the hull, but in a sustainable way that we just don't deposit everything in the floor bed around the ports, and how that's going to be disposed in a sustainable manner as well once it is collected. So all these aspects just have to be thought through, and we need to also within the organization provide the necessary support for this implementation. So the instrument that was adopted, the 2011 biofouling guidelines, again, not mandatory yet, but we gathered in these last 10 years enough information to embark a couple of years ago on the revisions of these guidelines, and you will get more details later on as well on this matter. What we're focusing on these guidelines, of course, is the management plan. It's necessary in order to gather the specific implementation of this instrument. The anti-fouling systems, that of course is in line with the anti-fouling convention. This is where we start connecting different conventions and instruments that have been adopted by the organization. Inspection, cleaning, and maintenance. Maintenance is key, cleaning is key. Of course, you then have to take into account that ship's time is valuable. And it's how we're going to do that in ports when the ships right now, nowadays, spend less and less time in port. And then design and construction. And here's where we go again into technological developments, and the organization also goes into not being that prescriptive in order to also promote this kind of development. The biofouling guidelines right now, of course, I'm focusing the revisions in enhancing main aspects: the risk assessment, inspections, cleaning and maintenance. From the organization point of view, what we're doing is also having a couple of projects, the glow fouling projects, in order to assist developing states on the implementations of these guidelines. Because it's not just developing the instruments and then leaving it to the member states. It is our big responsibility as an organization to gather the information, to provide that linkages between developed and developing countries in order to maintain the flow of experience and expertise. There's another glow fouling project, is the test biofouling, that we are also developing right now with the great assistance of the government of Norway in order to further enhance the implementation. And again, focusing on specific developing countries, doing the training in a way that those developing countries can become the trainee for other countries neighboring. So in this respect, what we do is not just to develop these instruments, but also to move forward in how we can assist everyone and have a global harmonized implementation. And I think I'm running out of time, and I'll try to push forward very quickly. Apologies for that. Lastly, you saw this at the beginning. Why I'm showing it again is because there's a lot of linkages between what we do here. I just spent a couple of minutes talking about ballast waters and biofouling and how the whole cleaning, how using the necessary coatings on board on the hulls of the ship will actually help us to tackle invasive species. But it also helps on a better designs of the vessels, better operations that will give us positive results when it comes to greenhouse gas emissions. So they're all connected. The more that we do aspects in one side of the ship to tackle a specific area, the more that we also compensate and actually enhance other type of regulations. And when we do this, we also have to look into what are the safety aspects related to this. Because if you look at the Ballast Water Management Convention, we're always going to have exemptions in environmental instruments where if safety is at risk, then that's paramount and that takes precedence. Doesn't mean that you can just use that as an excuse. That's why the record books are necessary in order to demonstrate clearly why those situations have taken place. Now, I'll come back later and I hope to engage you as well. I'll leave now the details to the next presenters. Apologies I crossed over the time. Thank you very much for your attention. It's been a pleasure.
Thank you very much to Mr. Dominguez, and no worries about the time, it was perfect. Okay, thank you for opening this session with that enthusiastic presentation and introducing the future of prevention of ship pollution. Let's give Mr. Dominguez another big hand, everyone. And next up, we have Colin Henane, Senior Policy Advisor of International Maritime Policy of Transport Canada. And in perfect succession, the presentation will be on opportunities to improve the Ballast Water Convention and next steps in the experience building phase. Let's welcome him with a big round of applause.
Good morning, everyone. It's a pleasure to be here in Busan, and I really want to thank the organizers for inviting me. It's my second time here. I was here in 2018 when the Ballast Water Convention had just entered into force to talk about how we were going to monitor the convention to determine if it needed improvement. And today is a very good opportunity to come and tell you how that monitoring has gone and what we are looking to do and address going forward. I'd like to thank Mr. Arsenio Dominguez for his great introduction to ballast water, which is fantastic because I actually did not have in my presentation all of that background about the convention and how it came to be. So that was the perfect setup. Okay. So I'm not sure why these slides are advancing automatically, but so the Ballast Water Convention turned 5 years old on September 8th, 2022. So that's just a few weeks ago that it's been in force for 5 years. And as Arsenio mentioned, it aims to prevent, minimize, and ultimately eliminate the risk of invasive species in ballast water. So the questions that I'm going to be looking at today are, is it working? What improvements are needed? And what are our next steps? So the convention requires ships to meet a performance standard, and the question is, why did we need to monitor its early performance? Ship owners were concerned about inadvertent non-compliance with the Ballast Water Convention and the performance standard, that they would install a ballast water management system, and despite their best efforts, they wouldn't meet the standard. So this led to a long debate at IMO about how we should be measuring this performance standard. And as a result, our guidelines de-emphasize sampling, and we agreed to a trial period to test methods for sampling during port state control. This concept of a trial period grew into the experience building phase, really to collect information to identify if parts of the convention need adjustment, and to avoid penalizing ships when testing the trial methods for sampling, and to develop a holistic package of amendments if we need it. And Arsenio showed you this diagram. The experience building phase has 3 stages: data gathering, data analysis, and a review of the text of the convention. And we've basically finished the data gathering and data analysis, and we're on to the convention review. So what did we learn when we gathered data on the Ballast Water Convention? Well, we got 4 years of data from 38 member states, 12 recognized organizations, 2 MOUs, and a number of other sources, and this was all analyzed by the World Maritime University. And what we learned is there's a very high rate of compliance surveys. 99% of hundreds of thousands of surveys have been assessed as compliant. And we have a very high rate of satisfactory port state control inspections as well. Over 90% of tens of thousands of port state control inspections have been satisfactory. But what we haven't seen a lot of is sampling to determine if ships are meeting the performance standard. This is very, very rare. Only less than 1% of port state controls involved any sampling. So this leads to a few questions. First of all, do we know how to sample? Because remember, we said we didn't have good methods. So it also makes us ask, are we happy with these rates of compliant surveys? Excuse me. And satisfactory inspections. Do we really know if ballast water management systems and ships are protecting the environment? So what we can do is we can look at the scientific testing. So although we haven't been sampling ballast water in port state control, we have been doing some sampling in testing, in scientific testing. So first of all, for the smaller organisms in ballast water, almost all ships are meeting the standard, so that's good news. But for the large organisms, the ones greater than 50 microns in size, we are not seeing results that are quite as good. So test organizations have been reporting an 80% pass rate, and administrations that have been doing science sampling have been reporting a 63% pass rate. In Canada, that includes some Canadian tests where we found a 55% pass rate. So first of all, different people seem to have different ideas about whether these systems work or not. And second of all, it's not coming out at 100%. When it comes to the chemicals and the active substances in ballast water, only about 66 to 73% of tests are meeting those chemical discharge limits. So I'm not going to do a lot more talking about that in this presentation, but I just wanted to highlight it because if we obviously are putting chemicals into the water through ballast water management systems that are harmful to the environment, that's something we're going to have to be looking at too. So as I mentioned, we have a wide variety of results here, and there's a question about why do we see different results. The answer is that a number of different methods are being used to do this testing. So it suggests that we haven't yet reached agreement on that. IMO has recommended a method, which is the ICES standard procedure, which is what Canada is using. Unfortunately, Canada is also the country that's come up with a lower pass rate using that method. Another reason that our rate may be lower is that a lot of our tests were done on treatment systems that had been in service for 3 to 5 years, instead of treatment systems that had just been installed. So let me tell you a little bit more about the Canadian experience. So we've done about 40 tests, mostly in Vancouver on Canada's west coast and on the Great Lakes. As I mentioned, about 55% pass rate, and about 10% of those are so close to the line that we're not sure if they're passes or fails, so we're assuming they're passes, but we don't know for sure. We have identified some issues with training and maintenance, low UV lamp intensity, incorrect chemical dosing that may explain some of those things. But I thought I would show you just a little bit of the data here. So what I've got in this slide, and I'm not sure you can see the mouse here that I've got on the screen. See if you can see my little red dot. No, I'll just explain it. So in terms of this graph, what we've done is we've taken all 40 of the ballast water tests that we did and we put them on one graph with the number of organisms. So, and we've sorted them so that the discharges with the most organisms are on the left, and the discharges with the least organisms are on the right. And you can see that on the right, the lowest ones, you don't even see how many organisms because the treatment system removed all of the organisms, or so many of them that you don't see them at all. So we have about half of the systems meeting the performance standard. You can see it's very low. On the other half, you can see some of the systems are just meeting the standard, and then there were a few tests where we had a lot of organisms still in the ballast water. And what we want to do is better understand why that's the case. So it's one thing just to look at the discharge, but you really need to know how hard was the water to treat. So we've now begun to look at this, and what we're finding out is that treatment systems basically reduce the number of organisms in ballast water by 2 to 4 orders of magnitude. And on 2 very challenging port tests, where we started out with hundreds of thousands of organisms, we were able to bring it down, the treatment system brought it down to hundreds of organisms. So what this tells us is the systems don't always meet the standard, but they're reducing the risk. And we've done some modeling of this, and at the current rate where we see about 50% pass, we're saying that there could actually be 5 times more discharges than exchange before we see our first invasion. So we're already reducing the risk. But if we could get those treatment systems to work 100% of the time, then compared to exchange, we could have 165 times more discharges before the first invasion. So this is an issue where treatment systems are doing well, they're already reducing the risks, but we know we want them to do better. So how can we detect problems in, this is the science testing. So how can we detect problems in real ships and improve performance? So one question is, can we detect problems better during port state control? Because don't forget, in that table on the left, right now port state control is 90% inspections are compliant, but we know when we do the science testing, only 63% of discharges meet the standard. So there's a disconnect here between the port state control results and the science results. So some people have suggested that we do sampling during port state control, and the convention allows this, and it can identify problems with treatment systems that can be corrected, but there are some feasibility challenges. First of all, it takes a long time to do sampling, and much more time than they have available in port state control. Second of all, we're developing devices to sample and to analyze ballast water samples that are easy to use. But the problem is that if you want to take this to court for enforcement, you need devices and you need procedures that will make sure that the results will stand up in court. And what we found is that inspectors, you can give them a lot of training, but in the time they have and with the scientific competency they have, there may be issues in terms of making it defensible in court. We also know that it's the large organisms that pose the challenges, and most of the devices test the small organisms. So if sampling in port state control is really challenging, are there other things in port state control that we could do to identify problems with ballast water management systems? Could, for example, officers look for indications of deficiencies in operation or maintenance of those systems instead of testing the water? And is there a role for the flag state of the ship to be periodically retesting the treatment systems on ships to give us confidence that the systems are working over the long term in performance? These are open questions. We need to understand that some issues may be outside the ship's control, and Arsenio was mentioning ports with challenging water quality before. Let me just give you an example of this, if you can see this picture. This is Hamilton Harbor in Canada. It's on the Great Lakes. And what you'll see is that the lake is to the right and to the top, and there is a sandbar that divides the main part of the lake from the harbor area. And, people have built this channel through the sandbar to bring ships into the harbor. The industrial area at the bottom is the steel manufacturing area, and that's where the ship berths are. Now, it may not be easy to see here, but coming in from the lower left is a marsh area that's bringing us sand and silt. So you get sand and silt coming in from the lower left and filling up this harbor with sand and silt. So compared to the lake outside, the water is muddy, the water is sandy, and this poses great challenges for ballast water management systems. This is not a problem that originates with the ship or the treatment system. This is a natural environment that poses challenges. So what do we do about this? Because we want ships to meet the standard. So one issue is, of course, ships that operate in these ports need to have good treatment systems that can handle the water quality conditions here. But we still are going to have challenges. So there's open questions here that we need to address that are going to affect ballast water management system manufacturers and vendors, flag states, port states, and ships. So how do we define this challenging water? How can ships plan for it? And how can ballast water management systems plan for it? Should we bypass ballast water management systems in these areas and just say, look, it's too hard, the ship needs to go, load the water, and we'll solve the problem later? And then if we do that, well, how do we solve the problem later in terms of the organisms that will be now in the tank? And what guidance or rules should be developed? And should we, in fact, be even looking at improving the code so that treatment systems are better able to handle these areas? This is an area of concern for us in Canada, because if we get into a situation where ships are commonly bypassing their treatment systems and the standard is not met, then we've invested a lot of money in treatment systems that are not being used, and we won't see the real environmental protection. So how do we address all of these issues? We've seen the performance issues, some problems around port state control, for example, challenging water quality. I mentioned chemical discharge limits at the beginning of the presentation. There may be other issues that are going to emerge here as we look through the data that we've received from the WMU. And so if you recall, the experience building phase had 3 stages: data analysis, data gathering, and a convention review. So we've completed the data analysis. It's time to plan the convention review. So MEPC has agreed in principle to a proposal. This is a proposal, incidentally, a number of countries co-sponsored this proposal, including Canada and the Republic of Korea. This proposal envisions that we agree to principles on remembering the goals and approaches to the convention as we work through these challenges, remembering that we want to eliminate invasive species. That's our primary goal. Identify what are the primary issues that we need to address here before we start asking ships to be in compliance with the performance standard on every discharge. So we need to identify the issues and the parts of the convention that need to be reviewed. We need to have a holistic consideration of the issues. So the last thing we want to do, and Arsenio mentioned this as well, is to go into the convention and start just changing things over here and over here and over here, because the convention is designed as one unit to address the problems of invasive species. So we need to identify what is the approach we're going to take as a whole to resolving these issues, and then make the adjustments that we need to the convention. And finally, develop those amendments. We know there are some urgent issues that we may have to deal with in parallel with the convention review plan discussions. There's been discussion about improving the ballast water record book. Arsenio mentioned sewage in ballast tanks. So some of these issues will continue to be addressed on their own, or they may be addressed in a preliminary way on their own, and then we may address them more completely in the convention review. So how will this work? So this is a proposal still that's been agreed in principle, but it's being discussed right now. So the idea is that we would extend the experience building phase, extend non-penalization for ships until we adopt amendments. So that would be principles and priority issues this year, the convention review plan and holistic discussions in 2023, the objectives for amending specific provisions in 2024, drafting those amendments in 2025, and then the package of amendments being approved and adopted in 2026. MEPC is very busy. There are a lot of issues being discussed, as Arsenio mentioned earlier. So most of this work is going to be done through correspondence groups. But we will take advantage of the opportunities during MEPC to have face-to-face discussions. The Ballast Water Review Group will be the venue for that. It's chaired by Ms. Leanne Page of the UK, who's also leading the correspondence groups, doing a great job. So there will be lots of opportunities for discussion and for progressing the work between sessions. So in summary, what we've learned from the first 5 years of the convention being in force is that it is helping, but that improvements can also be made. Treatment systems are reducing risks, but we need more performance and we need more reliability. New approaches need to be looked at to ensure that these treatment systems are properly operated and maintained, and that they keep working reliably over the long term. And that when it comes to challenging port waters, we can identify practical and environmental solutions for these ports. And we can do this through a convention review plan by 2026. And in closing here, I'd just like to highlight that we really have a great spirit of cooperation in the Ballast Water Convention at the moment, between ships, ballast water management systems, manufacturers, administrations, and port states. And it's through this spirit of cooperation that we will eliminate the risk of invasive species in ballast water. Thank you very much.
Thank you very much for giving us a detailed view of at which stage Ballast Water Convention is, and also for introducing us to Canada's case. Let's give Mr. Henane another big round of applause. And our third speaker is Jong-uk Lee, Director of WIPNEWS, who will address current ballast water management system technology of makers in the Republic of Korea and improvement efforts to cope with the limitation. So let's give a big round of applause to Mr. Lee.
Good morning, everyone. My name is Lee Jong-uk, and also known as Mike Lee to my foreign colleagues. It's a great pleasure to be here in 4 years since 2018, as Colin mentioned. The last time we had the forum was the 2018, mainly focusing on the BWM forum. Now we are back with the expanding discussion over greenhouse gas emission, biofouling, and smart ships as well. So the forum is getting bigger and more participation we expect. And I also like to appreciate the Ministry of the Oceans and Fisheries organizing this meaningful event for sharing the updated information, also that discuss over the protection of the marine environment. So I'll be presenting on the current BWS makers in Korea, and also the improvements efforts to cope with the operating limitations that we have experienced. So I also tend to speak faster, so bear with me. Also, you're not the only one speak fast. Koreans speak fast, eat fast, and work fast and hard. We all know, I don't need to mention about it, all ships has to be equipped with the ballast water management system by 2024 September. But there has been many things happen, especially under the pandemic. There's ups and downs, and even under that circumstances, many makers have supplied an installation of the BWMS. As you can see from here, that more than 26,000 vessels contracted from the Clarkson data, and Korea, China, Greece have been major parts of the supplying the systems. So we expect more than 10,000 vessels are left for the contract and installation, and we receive more progress on that. And many vessels already installed, and many vessels still yet to install the system, and they will experience some of the operation limitations and others. And all the stakeholders and shipbuilding discussed these operational issues along with the IMO, the required commissioning test as well, which that Colin mentioned. I will introduce the member of the Korea Association of the BWMS. Now we have 7 members. We started with the 13 members in 2012-13. And some of the makers has withdrawn from the market from some reasons, long delay of the convention coming to force, and also severe competition, as well as the it was a pity that some of the makers withdrew from the market even after the acquiring the type of approvals. But this is the industry and the market. Also, we have the international members, manufacturer members of Association BIMA. We have 16 members, and they act as an NGO at the IMO but the purpose of this organization is to promote and also that transport the common voices of the makers and the stakeholders involved in. So now I get into the Korean makers. First one is the Halla IMS. They have side stream electrolysis system, and with the experiences so far, they have installed more than 100 vessels, so that's for the retrofits only. And I know that they are working on the new system, new technology system, under the type of progress at this moment. So you can see there that thorough that design for the retrofits. And second maker is the high ballast of the Hyundai Heavy Industry. They have just received, not just, but they have received a new type of probar with the without filtration filter system. I believe that was the innovative system that showed first in the market. In early days, all the side stream electrolysis makers had to have the filter as a pre-treatment, but it was their challenge, and they have succeeded to accomplish the type of probar without filtration. I will get into the later for the troubles from the operating experiences, but the trouble comes from the filtrations. So one of the best solution is to get rid of the one of the best solution to solve is the getting rid of the troubles. So they have received a type of probar without filters, and now they are working on the hybrid system, also under the progress of the approvers, either filter mode or the no filter mode for the selection of the ship owners. Depends on the water qualities. So we'll see that another new type of probar on this later. Panasia, so it's a UV system. They installed more than 1,600 systems, and the strength of this company is the automation, smart factory of the manufacturing process. So just for the type of retrofits, they have delivered more than 600 vessels. So still going on with the retrofits and new builds as well. So you can see that robot system manufacturing that UV lamps and filters. And next one is the Essensis, which is the Samsung Heavy Industry. They have relatively lower dosage of the TRO. That gives the advantage of the smaller footprint and rather convenient installation. With its strengths, they have installed more than 1,000 retrofits in the market. You can see the various types of the vessels they have installed. And next one is the ARA 3건 Century, ARA Plus. This system used to have the plasma, filtration plasma and UV. But now that they have come up with the ARA Plus, that eliminating plasma process. So they have now only the filtration and UV systems. And the next one is a TACROS, the full flow electrolysis system, which type of product in 2008. They have many references from the new builds and the retrofits, also on various types of vessels. And this company, TACROS, also that developed and type of product on the side stream as well. There was some requirement, the request from the owner side, not just for the full flow direct, but also indirect system, especially for the tankers and the big fleet, big vessels. So they have emphasized on the international networking for the global service network, as well as the training center. So very important to train and update or the systems upgrade and the operation mode to the ship crews. Recent survey, I have found this from the Intertanko and the Martegma. They have issued a survey in 2020 and 2022 again. And recent the survey comes out with they have tested with the data report from the 87 vessels, 87 owners, and more than 2,000 PWMs installed vessels. So there were 10 technologies types and also 20 PWMs models. From these numbers, 78 system reported as the 4% of the system was not working, and 47% of the system working on without problem, and also there are some trouble on the 49% of the systems. From the 1,051 systems reported as working with the problems, the main issues comes from the control systems, filters, and the other issues like sensors, including TRO sensors, flow meters, rectifier, and UV lamps. So I see and I hear that many of these kind of the reports from the surveys from the ship owner side, and these are the ones that all the makers closely look into for any development. Also that report findings found it that the system performance was better than 2020, and operation still faced the major challenges. About half of them that are experienced mainly related to the control system and the filters. Insights on the preferred technology for vessels, size, and the type, and the maintenance costs and service performance. There is no one-size-fits-all solution. That's the owners that comment on that. And also proper installation and the commissioning, crew training, maintenance, and the operation within the system design limitation are key factors for achieving compliances. This is another report, actually the report that Colin mentioned, that Dr. Sarabelli of the Canadian government has surveyed, and that it is publicly open, and I see that we will see more and more the D2 sampling test data, even with a brand name on it. So everyone has to be closely look into the actual the D2 commissioning test report, data, and this has to be taken in account to the makers that further progress. And the troubles I mentioned, the makers also working closely to make the countermeasures for these problems. First one is the filter issues, as I mentioned, and I already introduced the Hyundai is without the Hyundai system is approved without the filter, no filter systems. So, and also we see the articles and news that coming up without the filters these days, who had the filtration in early days. I believe that due to the technology that advancement and development from the injection point and well mixing dilution method has been developed, and without filters that we can even achieve the D2 compliance and the in the end achieving the type approvals. And another trouble comes from the TRO sensors, which is a critical parts sensors to measuring TRO at the ballasting and deballasting. So far that the DPD method was the only system that has been approved, but recently the GASAMPO also that approved the use of the amperometric TRO sensor. This is an online sensors, so it doesn't require the samplings from the treated water or untreated water, treated water at the ballasting or deballasting. So some makers will try on this amperometric sensors. And also the turbidity was the big factor for the censoring the TROs, especially at the challenging water. And one maker developed the new sensors to take account of the turbidity factors. So this new technology that sensors are in the market is still under test, but type approved with type approval. So we'll see that these sensors is really working under the challenging water conditions. Also that the parts, critical parts of the equipment makes a big trouble and shutdown of the system. Sensors is one big factor, and also the others involved with the sampling devices. We have to get the sampling waters from the main ballast pipeline with from the high flow, that like solenoid valve and the hydraulic air pump. These are the ones that sampling the water. But when they get stuck from the debris or any failure of these small parts, I wouldn't say small, but in the size of, compared to size of the component equipment, it's rather small part, but it was not rugged enough. And these parts and sensors makers that bought from or the used from the land-based parts. So when we apply to the seawater, we saw that many troubles and kind of the fragile parts of the this system. So makers have been upgraded or find new components and parts to make it more rugged to the harsh condition of the seawater. So we have experienced it, and many makers also experienced it, and this will go on, I believe. And also that in early days that there are not many chances or that trials for the reliability test of this kind of the parts. So some of the makers have the reliability test facilities to test on the equipment and also the small parts as well. Regarding the port with the challenging water quality, the Republic of Korea that proposed the contingency measure, or we can call it as an alternative method to cope with the challenging water. So this is still under discussion. 7 and 9th meeting, we will also discuss on this, and the process will go on, and there will be some provisions on this contingency measures we expect. So Still, works to be done. WIPNEWS makers need to reflect on these troubles and issues from the ship's operational experience and continue to upgrade and replace components and parts which are critical to the operations. Countermeasures to the specific equipment and part, such as a flow meter, TRO sensors, failure needs to be further developed and included in BWN plan with the approval of the classification. Flow meter, from the ship, the flow meter used for the oil and fluid only. When we use this flow meter to the 6,000 tons per hour, that big flow that the ballast main tank, main pipeline, they have experienced some of the troubles. So as I mentioned, that many components and sensors coming from the land-based developed one, so we need to upgrade the systems with the more rugged, as a rugged system. Imagine that just failure of the flow meter or TRO sensor, every system shut down. So that's the main part that we have to look into. And as I mentioned, more rugged and accurate sensors need to be developed. And the contingency measures and PCWQ will be further developed guidelines is to set at MEPC 7IS meeting or 7IS or ATC meeting. And the proper installation and the commission, crew training, maintenance and operation within the system design limitations, are key factors for achieving compliances. Okay, so thanks for hearing my presentations.
Thank you very much for introducing us to who in Korea develops ballast water management system technology and also the technology, how it is progressing. Let's give Mr. Jong-wook Lee, or Mike Lee, was it? Another big round of applause. And ladies and gentlemen, we are now going to have a short break and continue with our program at 10:45. So please be back at 10:45 and we're going to continue. See you then. Ladies and gentlemen, in just a few minutes, we're going to continue with our presentations. So please take your seats now. All of those who are now entering the hall again, please take your seats. We will soon continue at 10:45. Ladies and gentlemen, we're now going to continue with our program. Please take your seats. So let's continue with our session 2 presentations. This time we're going to introduce to you Finding Oftedal, Specialist Director of the Norwegian Ministry of Climate and Environment and Chair of IMO's ISWG GHG. Now, Mr. Oftedal presented us with a lot of insights already on the first day, so we're looking forward to what he's going to talk about today. And I'll give you a hint. It's on the importance of biofouling management and the current status of discussions about biofouling. Let's welcome him onto the stage with a warm round of applause.
Thank you very much for that introduction. It is a pleasure to be here today as well. And indeed, I'm going to speak about the importance of biofouling management and the current status of the discussions about biofouling at the IMO. So let's start with the basics. The ecosystems in natural balance and development is the basis for the natural balance and the development of all. The oceans, of course you know this as an ocean nation in the Republic of Korea, is critical for the global climate system and also the planetary health. We know it is absorbing CO2, we know it regulates temperature, and we know it is a very important food source providing 20% of the animal protein consumed by humans. Unfortunately, we also know that ecosystems and the oceans, which is our topic today, are posed with several threats caused by human activity, including shipping, as was presented by Mr. Arsenio Dominguez previously today. There are many threats to systems in the oceans, and the invasive aquatic species is one of the major ones. fact, as stated as the Glow Fouling website, IMO project Glow Fouling, says that the introduction and establishment of invasive aquatic species is considered to be one of the most and the greatest threats to the world's freshwater, coastal and marine ecosystems. Later this year, in December, there will be this long-awaited COP meeting of the Biological Diversity Convention. That COP meeting, Conference of the Parties, will be held in Montreal in Canada. The convention is a framework convention to protect biodiversity. It's just like the UNFCCC is it's a framework convention on climate. The Biodiversity Convention is the framework for biodiversity. We have translated that into our action at the IMO. Mr. Domingo showed the totality of our work, and more specifically, we have the topics of today, the ballast water management and the biofouling, as a specific activity at the IMO, which is our job in order to protect biodiversity. And that is translated into the specific of the equipment Mr. Lee presented to us. That is protecting biodiversity in practice, doing this globally for the shipping sector. On biofouling and the introduction of invasive aquatic species, we have a lot of research in various countries and also globally to identify that indeed this is a threat to our ecosystem in the ocean. This year, we had a presentation of a report in Norway, which was initiated by my ministry, recorded that at least 42 invasive species are observed in the Norwegian waters. Most recently, we have now what is called in the popular term sea vomit, which is Dideminum vexillium in Latin, is identified in our waters and poses a threat to the ecosystems in those ports. And then we have also now identified some risk areas with high and lower risk for the introduction of aquatic species. And biofouling is considered to be the main vector. This is also done in Denmark, which is publicated recently, and they found that 130 non-indigenous species are introduced in Denmark. In Europe, in total, since 1949, they have identified over 1,000 invasive aquatic species, and they have identified that actually biofouling is one of the main vectors for spreading. There are literature and science representing the biofouling as a main vector in New Zealand and also Hawaii. So that we have a problem caused by biofouling is very well documented. Now, the question is, how can a clean hull have fouling? And actually, when a clean hull comes into the water, it doesn't take a long time until actually there are some biological material which is adhered to the hull. After the first 24 hours, you will have bacteria, and then followed by the bacteria, you will have biofilm, a slime layer, and then the biofauna will start to increase, and after 2 to 3 weeks, organisms such as tube worms, barnacles, etc., may have attached to the ship hull. So from this newly painted, beautiful ship hull duck, it doesn't take a long time when it comes into the water until the biofouling starts. And we have then various grades of fouling. We identify that and we define it in guidelines as microfouling and macrofouling. And you can see here in the bar below how this is then identified when it comes to the the sort of fouling and the size of the foul material, and this is some of the important aspects also in the guidelines, which I will present later on, where we have the identification of the amount of fouling and then what to do with it. So it was presented by Mr. Dominguez as well, but I just wanted to present to you the important dates. And we can see that in most of the IMO work, it is a kind of system where we first identify an issue as a problem, then we develop guidance material in the form of guidelines, and then we also then decide, is it a need for more? And what we have done on the issue of biofouling is indeed to have the first version of the guidelines adopted 10 years ago, and now we are into the process of revising. In addition, the IMO is also delivering important assistance to developing countries through their projects. Where are we in our work? What is the status of our work? What are the issues we are discussing? And what is our timeline? Well, this work is being undertaken in the subcommittee of the Marine Environment Protection Committee. And the MEPC is then taking a decision on all the IMO framework on environment, meaning when the updated guidelines is to be finally considered, it is the committee which undertakes that job to decide on those issues, to consider and decide. But the actual work is now undergoing in a subcommittee of it. So it is well underway in a correspondence group, meaning that we communicate member states and observer organizations by correspondence, where the group is then coordinated by me, and the participants, they get certain questions, and then I receive feedback, and on that feedback we can then further develop the content of the guidelines. So in 2023 we have a target completion date in our work, and let's now look into what are we discussing, what are the content of these guidelines, what are, let's say, not difficult issues, and what may be the difficult issues. Now, this slide is presenting the various sections of these guidelines. Obviously, we need to identify who's going to use those guidelines. Who are they addressing? They are addressing, of course, the member states, and of course, then the relevant authorities and industry and other relevant stakeholders. So it is not guidelines just for one specific entity, but actually the wider maritime community. We have identified what the objective, and actually follows the same objective as a balanced water management convention, to minimize the transfer of invasive aquatic species through the biofouling. Then we have various chapters which we are looking into the totality of what may cause biofouling and how can we address it, into the design and construction, and as well as installation and maintenance of anti-fouling systems. Now, we saw also in the slide, Mr. Dominguez was presenting on this one, that the ship hull is not just let's say, a very clean structure. It also has niche areas where there may be higher rate of fouling than in other areas. So the first three bullet points, you can see I have a green line, meaning it's not very problematic. Coming into the next three bullet points, there we have the real discussions on the content of these guidelines. Now, in order to take action, in order to prevent biofouling as a vector to spread invasive species, we need to inspect ships. What are there? Is it any fouling, and how frequent shall we then inspect? So we are discussing the inspection intervals, and also if you're going to apply a risk assessment for the defined intervals to inspect. Meaning that if you have high risk of fouling, you need to have more frequent inspection than if you have a lower risk of fouling. And I'll show you a slide on that later on. The next issue is then we have identified fouling rate. So this is then for the purpose of defining the amount of fouling then and the recommended actions to be taken. So this table is then to be included in the guidelines and of course have high relevance for the ships to take actions, for member states who want to apply these guidelines, what kind of control regime they want to include, and also it has high relevance for the problem as such as spreading of invasive species. And then the third element is recommendations for cleaning and capture rates of fouled material for in-water cleaning. In real life, the cleaning will be taken in water. Of course, the ships are in dock at least every 5 years, but for addressing the biofouling as a vector, we need to have in-water cleaning, and then we need to define the capture rate, meaning we need to collect the material which we have cleaned. There are, of course, technologies for doing this. Then I come to the issue of all these will translate into technologies. So, meaning that if we have low standard, we have a possibility to have technologies which are not that good. And if we have higher standards, I think they will also call for innovation and let's say, better technologies. It's just like the ballast water management convention. We can see that we can have a high degree of, very high degree and compliance with the standards developed by the convention by the manufacturer of such technologies. The same can be translated into the biofouling, that establishing good standards in the IMO framework, which also will be a clear signal to the innovation and development of the treatment systems which can deal with this problem. Now, if we continue on that list, we have then, which we can find in most instruments, you need to have a management plan and a recording on what you are undertaking as your biofouling management. So this approach you can find in many IMO conventions, including the ballast water management convention. We have included that guidance as well. And it is not the kind of problematic discussion within the group. It is just to make it more precise and better. And then we have a section where we then have dissemination of information and training and education of those which are involved in the ship's crew, etc. Further, we have a list of technical appendixes, and in a totality, that is what is in process. Let's continue on the key issues where we are discussing cleaning, meaning capture rate is very important. Should we define the capture rate, and also if we define a capture rate, how can we then test and ensure that the systems which are doing the cleaning can meet those capture rates? And then there is this issue about so-called proactive cleaning, which we are discussing right now. Should we allow for continuous cleaning of ships without capture as they go in order to prevent the biofouling? Yes or no? And if yes, on which conditions should such methods be used? And this is perhaps the most problematic part of our discussion. And then, of course, as I also informed, the inspection frequency. So if you have frequency with rare inspection, of course, then the risk of having biofouling on ships, especially in the niche areas, is very high. And then the question is, are we then really addressing the question? So, not the question, but the problem. Now, I'm not expecting you to look into this in detail. This is also a part which is included in the guidelines, which is then a flow chart identifying how you can identify the risk for fouling and how that can translate into the inspection rate. So it is a part where you have various yes and no questions. And for instance, one issue is whether you have damage on your anti-fouling systems. Is that leading to then higher or lower risk? And the point, this system is then for ships to use in order for them to know where they, if they want to have more frequent or not less frequent inspection rates. So now, it's of course ships biofouling we are addressing, but IMO is also addressing other mobile structures. So this slide is just to identify that in addition to ordinary passenger ships and cargo ships, there are larger mobile structures we can have a very high rate of biofouling, and they are also moved from area to area and pose a risk of biofouling. It can be a mobile offshore platform, and you can see here a picture of a mobile offshore platform in Norway being then actually cleaned and material was collected. And I also have information that such platforms have not been cleaned before they, for instance, were moved to Canada. And I have information that some of the species on those platforms should not be introduced to Canada. The point why I'm saying this, in order to take action as a authority, you need to have the legal basis to do that. And that is why conventions are so important, to provide the legal basis to take action to prevent the spreading of alien invasive species. Now, the Ballast Water Management Convention is a very important convention, but it has some cost because when you do the treatment, you use energy and you are doing some extra work. My view, looking into the topic, biofauna management is win-win. We will minimize the risk of spread of invasive aquatic species, posing a substantial risk to marine ecosystem and biodiversity at very important cost, but also significantly reduce the greenhouse gas emissions and air pollution, and consume less fuel, save money. And the last point, which we also need to address, and it is also related to anti-fouling system and treatment system for the ship's hull, is the release of microplastic from systems. The issue of microplastic was also addressed by Mr. Minka, so that is a thought that would be. In general, it is win-win. And I think I have used my time already, so therefore it's time for me to say thank you very much for your kind attention, and please follow us when we progress this work at the IMO. Thank you very much.
Thank you very much. It's good to hear that the biofouling guidelines at the IMO that you laid out for us are well underway. Let's hope for a win-win future as well. Let's give Mr. Oftedal another big round of applause for that presentation. And now let me introduce you to Kyung-Soon Shin, Director of Korea Institute of Ocean Science and Technology, who is going to talk about biofouling management R&D status in the Republic of Korea, techniques development for management and evaluation of biofouling on ship hulls. Let's welcome him with a big round of applause.
예, 감사합니다.
Thank you so much for a kind introduction. Today, I'm going to talk about what has been done on biofouling in terms of research in Korea, and especially I'd like to focus on what is happening on ships with the biofouling problems and how we are cleaning those ships and how we are assessing those ships. Before I go straight into my presentation, I'd like to thank the Ministry of Oceans and Fisheries for giving me this opportunity to stand before you. As you can see on the slide, this project has been done with the organizations I listed up on the slide. Now let's take a look at the picture on the slide, especially the left side. Divers manually are dislodging biofouling. This is the method we used to do only a few years ago, but we did so much in R&D, and we have developed technology, and we are trying to do what you are seeing on the right. What we are trying to do here is biofouling cleaning that is done remotely, and byproducts coming out of it can be observed, and it can be treated on shores, like at ports or at wharves, and so we have been moving from the left to the right. I think we will have technologies that will make this happen in the future. We have two parts under this project. One part is development of in-water cleaning systems. And about this project, you will hear more details in the next presentation. In my presentation, I would like to focus on how we are going to assess the effectiveness of biofouling cleaning. This is the main pathway for invasive species. As you know, the main pathways include ballast water or import of seafood. Not only seafood, but species, sea animals for decorative purposes. And we have guidelines and even a convention to manage ballast water. And there have been advanced technologies to deal with ballast water management. The biofouling guidelines or convention are a little bit behind the convention and guidelines of ballast water. And if I understand correctly, IMO is revising guidelines of biofouling, and some countries have their own biofouling management regulations. And there are two perspectives that deserve our attention when it comes to invasive species. Advanced shipbuilding technologies accelerated speed of ships. It used to take a month to get to the States by ship, but now it takes only a few days. This also means that invasive species can survive for a longer period. Another perspective is economic point of view. As you know, as we have an increasing number of free trade agreements and the size of ships have gotten bigger and bigger, cargo volume has increased as well. So we are seeing more and more ships operating between regions and countries. That means the movement of invasive species have been accelerated. Other speakers also pointed this out. We have this fuel technology. We have to talk about the friction factor. It can cause resistance. On smooth surface of ships, the friction factor is very low. But once the ship's surface has biofouling, especially macro biofouling, the surface of the ship is rugged and tough. That requires more energy consumption. And this is a data from IUCN, and it talks about the pathway of the invasive species. It says biofouling is bigger origin of invasive species compared to ballast water. I think this is one of the reasons why IMO is trying to revise biofouling guidelines. Two previous speakers already talked about this guideline, and what I want to talk about here is Global Fouling Partnership Project. When the BWMS Convention took effect, Global Fouling Partnership Project has made a great contribution for the implementation of the convention. I think most of you would agree with that. I believe Global Fouling Partnerships Project is still making a contribution to implementation of the convention. So I think Global Fouling Partnership Project can make contribution to guideline or even a convention of biofouling. As you know, New Zealand, California in the States, and Australia, they have their own national or state level regulations to manage biofouling of ships. So ship owners in those countries and regions have to be well aware and have enough information on the regulations. So some of the Korean shipping companies may have to clean their ships before entering waters of New Zealand. So we are seeing more and more attention in biofouling. So Korea also started a biofouling project. So today I'd like to talk about how we have to manage biofouling and how we have to assess the risks that come from biofouling. Actually, Korea is doing this research under the project I described earlier. So I'd like to share the details of the project. Under the project, we have three parts. One is risk assessment of biofouling. Second, what management system we need. Third, what regulations we need. So we have these three parts under the project. As I said earlier, we have this risk assessment. One is biological risk assessment. The other is environmental risk assessment. We will do an assessment in water cleaning systems in the future. First, let me give you some details. When we do the biological risk assessment, we use this risk assessment methodologies to check what biofouling is coming into the Korean water. We set up a criteria for the assessment. We use microscopes or NGS, like a molecular mechanics and molecular technologies. So here we are trying to find the amount of biofouling and the types of the biofouling. We are also trying to look into the survivability of biofouling. If you look at the bottom right, you can see a flow chart. This is the system. This is a diagram of the risk assessment. So we also came up with a scenario for in-water cleaning of biofouling. And after gathering the assessment results, we will come up with a comprehensive research results. And this is an assessment system that had been done in New Zealand for about for about 10 years. 20 years ago, there was no guideline for biofouling in IMO, but now we have a guideline. So we are trying to come up with and develop a guideline for biofouling that integrates Korea's water condition. Next, what biofouling and the size of a biofouling is harmful is researched, like you can see on the slide. And the byproducts of the biofouling can have microorganism that is alive or that is dead. So we split the two. We have different assessment system that can be applicable to the two. So they have a different nature, and each biofouling species requires different assessment method. So we are trying to develop different assessment methods that can be applicable to different biofouling types. This is environmental risk assessment. It has two parts. One is environmental, one is chemical assessment. And there could be some active materials in water cleaning, in the bioproducts, while in water cleaning is done. Let's take a look at box number 1 and number 5. First, we calculate the load in the byproduct. We also look into the physicochemical properties of the byproduct. That is box number 1. We are going to establish the fluid mechanical system. That is number 3, box number 3. And with all that, we will do the environmental risk assessment. And we will, based on that information, we will collect additional information. This slide shows pictures that what we did last year. This is sampling activities that we did 4 samplings last year. The picture is just too small to see. The divers went down under the water and they dislodged the biofouling from ships, and we collect the samples for assessment. For example, I'd like to tell you about heavy metals. Now you are seeing graphs, 2 graphs. The graph on the top shows concentration of dissolved metals, and the graph at the bottom shows concentration of particulate metals. The concentration between the two are quite different. The dissolved metals concentration is higher, and particulate matters can be removed by precipitation, but for now there is no technology available to get rid of dissolved metals. That means most of the dissolved metals will remain at sea. Even if the concentration of dissolved metals is low, it can have a huge impact on ships. That is why we are doing researches on concentration of dissolved matters and compare concentration of dissolved metals and concentration of particulate matters. And to find out how concentration of dissolved matters affect ships, we are trying to predict the discharge of ballast waters pollutants. Here, we came up with some modeling, and we are collecting information on tide and sediment conditions and water quality conditions. We selected 5 ports in Korea, including Incheon Port, to build this MEC modeling. For your information, this modeling is for risk assessment modeling of effluents that IMO used to assess active substances in ballast water. Next is in-water cleaning. To come up with in-water cleaning criteria and AFS biocide criteria, we selected 6 invasive species that can cause biofouling, and out of that we came up with toxicity parameters, and we calculated HC5 value that can protect 95% of the ecosystem. And based on this information, we are trying to provide ecological protection recommendation criteria. Next, we are trying to develop a management system for biofouling. For that, we have to first discover what harmful biofouling is coming to Korean water. For that, we use biofouling materials, and as you can see on the right, we are building this management framework. For that, we check information on in-water cleaning. Then we conduct biological risk assessment, and that should be developed. That should be developed first, as I said on the previous slide. When the biofouling has a low score in the risk assessment, we follow this flow. Then we decide where the cleaning should be done and when the cleaning should be done. When the risk assessment results show the risk is high or the risk is uncertain, we look into the list of invasive species we decided earlier, and then we decide whether this biofouling includes invasive species we decided earlier. Then we encourage and recommend in-water cleaning, including dock cleaning, and we designate certain waters for in-water cleaning. If the biofouling doesn't include invasive species we listed up earlier, we can take another measure. So nothing has been fixed yet, but we are building this management framework. And we also have to monitor invasive species that came with biofouling. We have 2 monitoring systems in mind. One is to monitor hull. Here we are trying to use ROV, and we will take a look at pictures to identify invasive species. KIOST has a branch office in Arctic area, and we also have an experience to identify invasive species in Arctic area. And the experience told us that a species that is 5 centimeter or smaller can be identified through ROV. So we are trying to apply ROV to biofouling as well. Of course, this is what we do. We use eDNA to identify invasive species and to monitor them. There is something called a RAS. This has been used by Canadian scientists for long, and this can be also used. We will also use this for monitoring biofouling. Next is data modeling. And all data we collect under this project will be used for database. Once database is built. We will do risk assessment, and we will make our management process more effective. Lastly, regulations for biofouling is needed, as I mentioned earlier. To introduce a new regulation, we have to review IMO guideline, which is under revision. There are some issues that I personally think is important. Some of the previous speakers pointed this out as well. And the efficiency should be 99%. And inspection interval and cleaning interval, they matter as well. Personally, they should be set up based on scientific data, but we still don't have enough data, so we need to collect more data on necessary cleaning interval and efficiency. So personally, I think that's important. After in-water cleaning, we are going to have byproducts as a result, and we also need to come up with a method to treat the byproducts. I believe IMO guideline will include the method to treat byproducts of a biofouling, whether we will incinerate them or whether we will bring them to a landfill. So we need a clear regulation on how to deal with byproducts of a biofouling. Otherwise, the byproduct will have an environmental negative impact. Guideline is not our ultimate goal. We need a law or convention, at least in Korea, so that we can effectively manage biofouling. Lastly, this is the picture that I showed you on the first slide. We are, as I said on the first slide, we are moving from left to the right. If we can get there on the right, we can reduce the movement of invasive species, and we can effectively manage biofouling. I have this hope. With that hope, I'm doing this project. That concludes my presentation. Thank you for listening.
Presenting us with the direction research and development has to go in terms of biofouling management. Why don't we give Mr. Shin another big round of applause? And now we have come to our last presentation for session 2. And this presentation will be done by Yushik Kim, CEO of TAS Global. And the presentation is titled Introduction of Development Status of Underwater Vessel Cleaning Robots and Demonstration of Prototypes. Sounds interesting? Let's give him a big round of applause.
It's almost afternoon, so good afternoon. My name is Yushik Kim. I'm a CEO of TAS Global. The title of this presentation is about introduction of the development status of underwater hull cleaning robots and related research information. But in order to understand what we are developing or what's IWC in water cleaning is, I think it's very important to explain what's market is going, what kind of needs there are, and what kind of technology or performance we can provide to the world. So a short introduction of myself. Actually, the TAS Global is a Ministry of Oceans Fisheries funded company. We are in-water cleaning robot developer, manufacturer, and service provider. And also, I am a chief of the world's largest in-water hull cleaning R&D project. And we are working with the all the national research institutes in Korea, for example, KIOST, I think their research ranking is like top 1%, and Korea Maritime Equipment Research Institute, and they're they do the most biology testing about WTS in the world. And KRISO, this engineering research institute, makes really deep sea, 2-kilometer deep mining ROVs or AI ROVs, very top of their field, and also Korean register. And also, I'm a chair of a 2022 Global Industry Alliances of the Global Following Partnership Project. So the new needs is rising in the shipping industry and also IWC, in water cleaning, because of the greenhouse gas reduction convention and ocean protection from invasive species. IWC demand, IWC is in water cleaning. It's hard to remember, but I know so IWC demand is soaring I expect to soar from beginning of 2023. It's already been rising. And because it is very important to know prior to actually you have the biofouling, there are needs for biofouling pre-risk assessments. And the whole performance monitoring, not many company has this technology built in their system. And also, IWC performance evaluation before and after cleaning. And also because the demand is rising, there gotta be there's demand for more flexible hull cleaning in very flexible situation. Let's say like short stay and has to be cleaned in anywhere, and also the capacity. And of course, environmental technology is necessary. I will not talk about this because it's necessary. You gotta do it. You have to do it. I don't think it's difficult. But the question is not how much environmental you are. No, the difficulty is how much efficiency you have when you are environmentally clean. And these are recent developments in IWC, especially in Korea. Basically, there is fouling risk alarming system, AI alarming system. When your vessel is in certain water location with a certain temperature, with the idle time, then the AI will tell you when it's you need to do the inspection or something. This one especially is developed by KCC. And I believe, AkzoNobel and Yotun, they also have this kind of technology. And whole performance monitoring is being provided by many entities actually, including the Hyundai Heavy Industries. And we will provide the service too, that's global. And also, IWC performance is being accumulated. The performance of the IWC is being accumulated, so it can be proven by third party. So right now, like LOA 350 meter ship full hull cleaning is done in 8 hours in Korea. That's the fastest in the world, and probably like 3 times faster than anyone. And also IWC in fast water, like anchorage, is being provided up to 3 knots. Also, 99% of bio, non-bio, and metal particles are being collected, treated up to bigger than 10 micro. But in the near future, autonomous shipping abrasive AFC, which means the AFC, the anti-fouling coating is built for the ROV hull cleaning, will be introduced in the market starting, I think, late this year or early next year. And also, there will be fully autonomous ROV cleaning, AI inspection. Now we have about 99.6% accuracy with species. And the LOA 350 meter ship full hull cleaning will be done in 4 hours. And also the water treatment system, which is like 99% of everything, including melted metal. The melted metal has not been really conquered, but it will be introduced, and you will be able to buy, if you're an IWC company, you will be able to buy off the shelf. So the new needs, why this hull cleaning is increasing? Because as of 2019, already 48% of all ship is CII DNE. And also the revised global fouling guideline will pass in 2023. It's only guidelines, not a convention. But I think most of the country I speak, I mean the diving company or ROV operator in most of the country, from South Africa or East Europe or West Europe, they're preparing their own regulation prior to the convention. Pretty much everyone is preparing. So the problem is the IWC demand is rising, but also the supply disruption is happening. Because the conventional divers are losing their ground fast. And also the IWC with ROV, they're gaining ground fast. About the pre-biofouling risk assessment, if you're a sailor, seaman, or if you are anyone related to the shipping industry, we all know by experience, temperature and the location and the duration of the stay has something to do with the level of fouling you're getting onto your ship. But it's an experience. It's not a AI tech, or it has not been software. And the whole performance monitoring, we all know it's very difficult because there are too many variables, like the speed of current, the direction of the current, and the wind, the draft, how much load you have, and etc. etc. There are too many variables, so it's very difficult to measure actually how the hull and the propeller is performing. And also IWC technology. Every IWC technology have a different performance. So I think the market, the ship operator, they want to know which one is better or not. And also, IWC means in difficult situations. For example, ship is only staying for like 15 hours and they have about 6 hours of bunkering. Then there's only 9 hours of hull cleaning, and then if the regulation kicks in, you have to do it. I mean, even if you have only like 5-6 hours of stay. So there gotta be a system that really cleans fast. And more cleaning area, for example, like let's say you have a tanker and you're filling up, you're loading at the Saudi Arabia, and of course you cannot clean while you're loading. It's illegal to clean any kind of chemical or like oil tankers while they're loading. So the only option is when you're coming to Singapore, you can probably clean in the anchorage of Singapore, but when the water is fast or if you're bunkering, it becomes out of question. Then eventually you come to west coast of Korea, which is the water current can go up to like 3.5. Then you cannot clean. So you have very difficulty. But there gotta be some kind of like cleaning option for these kind of tankers and bulk carriers too. So what kind of performance do we have? Performance in every water cleaning is different. Like the numbers you see is statistical forecast, not the actual measurement of the evaluation. So ISO 19030 based hull and propeller performance results after IWC is being accumulated. I guess if you have about 100 cases, you can really make it statistically justified. And the goal we have is we want to have this certifiable results, and the result is very close to the dry docking performance level. So then the ship owners will know what kind of they can compare the IWC, the quality of the IWC. So this is the real result we have. For example, we did this is two examples of Musk Alwife and Hapaloid. Musk is about LOA 337, and because it only had 15 hours of stay and they had 6 hours of bunkering, and the crane of the terminal, not letting us in, so we really had only like 9 hours to finish up. So in that way, we implemented 4 robots and about 10 operators, 5 divers, and at the end we finished in 8 hours. A few days later, we had about LOA 366 meter ship. We only had certain time, so we finished up in 10 hours. Basically, we are a zero clean company, and yeah, we just finished it. And in the west coast of sea, because the sea, depth, water depth between the water between China and Korea is shallow, so there isn't much. The water is really fast. It can go up to 3.5 knots during the springtime. So we cleaned these two vessels in a row. And first day they were at a dolphin pier, so it took us about 8 hours. And the next day we tried to finish before the spring tide happened. So we finished up in 4.5 hours. Although we added like 4 robots. So this is a video. It's not running, but so basically, being environmental is necessary. So from my point of view, a lot of people talk about how important it is, and from my point of view, from a technical point of view, it is not a difficult thing to do. It is not a difficult thing. Capturing alone and filtration alone is an easy technology because you just have a big bucket, and behind it you have a just big pump. Just suck everything out and you put into a filtration system which is already reaching its very high technology point. But the issue is, the rarity is, how to move with the bucket, with the large bucket, and that's the key point. Like how well, okay, the PC doesn't have codec, so can't run the video, but basically, how well you run the ROV with this. It's always good to show you videos, but our ROV has this underwater non-slipping technology. We have a underwater towing power about 330 kilogram force. Basically, we have the only underwater non-slipping technology, so you can move around real fast and real nice. So in coming years, in 3 years, due to the ministry, very gratefully, they have provided us with about $15 million in R&D. And with that, the funding, we will be able to finish LOA 350 meters in 4 hours, maybe in 3 hours. With 4 robots, and if you have 2, it will be about 8 hours to finish it. Now we are doing 8 hours with 4 hours, 4 robots. And the cleaning time is getting like 20-30% efficient every year. And for the first time in the world, I think, there has been this kind of technology. We're combining some kind of like very high-pitched sonar technology, including the inertia and gyro sensor. So we'll be able to provide the true autonomous, multi-autonomous hull cleaning system. For example, 4 robots hull cleaning autonomously at the same time. Plus, we are in the process of developing this deep learning AI inspection. Right now, we have about 96% accuracy of finding the biofouling, and we only have 5 kinds of species installed in the system, and the accuracy is 99.6. We're putting more species, and we're trying to make more species. We are trying to work with different countries to add more species, so we can have pretty much every species in AI. And about the filtration system, about 2 years from now, or 3 years, there will be a water treatment system which can basically do everything, including the melted metal. You can actually filter the melted metal. And it will be available from off-shelf. And I believe not only this company called SNCs, but Tecros and maybe some other BWTS company will be able to provide this with. So, and also everything will be integrated into one system. All cleaning will be monitored by, and also the water treatment, it will be monitored. So it will be a real-time monitoring of the hull cleaning and the water filtration system. And this is the fun part. Actually, I cannot tell you much about this because we have a fantastic idea of how to make this new testing method for capture. And this is we are doing something very fascinating, and I think we're doing, can't really tell you much, but I think we kind of can probably nail this on how to measure actual capturing rate. Not the big ones, but also the micro level ones too. So that's it. Thank you very much for listening, and I think I finished in just good time. Thank you very much.
Thank you very much for that presentation, and also thank you to our cleaning robot over here.
Oh yeah, actually we have the actual working ROV right here. It's if you have any question, you can answer. So please come and look at it.
Looking
Thank you.
forward to that. Thank you very much. Let's give him
much.
another big round of applause. All right, and that wraps up the presentations of session 2, but we will get ready for a panel discussion in a bit. We're going to have a few minutes of a break while we set up the stage. So please be back at 12. We're going to start at 12 with the panel discussion. That would be in around 10 minutes from now. See you then. Ladies and gentlemen, we are soon going to start with a discussion panel, which will involve all the speakers that we heard of earlier. So please take your seats now. We will soon begin with our panel discussion. All right, ladies and gentlemen, I hope you're refreshed and we can start with our discussion session. So it looks like our panel of experts and our moderator are already on the stage. So I will toss it over to our moderator, Arsenio Dominguez, Director of MED of the International Maritime Organization, who is going to moderate the session. So the microphone is yours. Let's welcome them with a big round of applause.
Almost ready. Thank you very much. Thank you for the organizers for allowing me to shape things up a little bit here. The main reason why I wanted to stand is because it was a very long flight from London to Korea. So I still need to stretch my legs. Plus, it's easier for me to also see you here rather than bending my neck over there. Thank you for all those presentations. The interesting thing that I've been taking from them is, in particular, the similarities between the Ballast Water Management Convention and the biofouling guidelines and the work that we're doing there, how challenges have been met with the ballast water management systems, how we're still learning from it, but also how similar the work that we are planning to do in the development on technology is already taking place when it comes to biofouling. So thank you for providing all that very interesting and important information. I want to start with something that was mentioned as well in relation to how much the Republic of Korea is actually investing in working towards research and development. And that's something that is really appreciated. I got a report as well that since between 2021 and 2025, the Republic of Korea has committed to allocate $20 million for research and development just on biofouling alone. And I think that deserves actually a round of applause, because it is really important to actually invest in the future of the protection of the environment. Now, I'll start, and this is also not rehearsed. They don't have questions in advance. That was my decision. There's no such thing as a wrong answer, and I'm not going to put you on the spot. They are not tricky questions. It's just good for everyone here to hear you talking about your views beyond what you put forward on the presentations. So I'll start with ballast water, and I'll start with Colin on this one. Now, you talk about, Colin, and I go straight to the issue of compliance. Very high rate of compliance in relation to the experience building phase. However, not sampling. not so much on the sampling, and we know the reasons why, but we expect that sampling would actually give us more information into how we are working and how the ballast water management is performing. Why do you think the reasons are, and what could be done to enhance sampling within post-stay control? What are the challenges, and what do you think that we can actually do about that?
Yeah, thanks. That's actually a really good question, Arsenio. So thanks for that. The challenge for port state control really is the very limited amount of time there is to assess a large number of conventions of the IMO. And I mean, we were joking last night at dinner that ballast water is the most important convention at the IMO, of course. But there are people who have advanced the idea that some of the safety conventions that deal with life safety and these kinds of things are also important, and I have to agree that that's the case. So a port state control officer may not have time to set up sampling equipment in the engine room, even if they can figure out where on board the ship to take a sample, because there's a lot of variation there. So, but we know that ultimately having these systems working properly is what's going to protect the environment. And filling out the record book correctly or having the right certificate on board, of course this is very important, but it's only part of the picture. So what we need to do in port state control is find a middle ground between just testing the paperwork, just looking at the paperwork, and the very difficult problem of having a team in the engine room pulling ballast water out of the lines and doing scientific sampling. And so what we can do there is, we can look at, has the system been installed, operated, and maintained correctly? Because at the end of the day, that's what we can expect the ship to do, and that's what's going to provide the best assurance of protection for the environment. And for the port state control officer, that may be doable in the time available to assess correct installation, operation, and maintenance without having to start a science project in the engine room to sample the ballast water.
Thank you for that. And I'm going to pick on one word that you mentioned in your answer, and it's time.
Yeah.
And that's going to take me to Mr. Lee, if that's okay. Because this is one of the things that you also mentioned in your presentation, you know, the time that is needed. Now, you focus a lot on the, sorry, you gave us information about the sensors that have been developed now. Do you think that there's further technical development that can be done to address what Colin was saying in relation to more technology for onboard sampling, not just at the port state control level, but throughout the journey of the ship, so the information is readily available? It's for you.
Sorry, I was expecting that was for the Korean, and I didn't pay
That's
attention.
fine.
So
That's fine. I'll repeat it.
Yeah.
You talked about all the developments that have been carried out in relation to sampling, the turbidity, for example, the new sensors that have been developed, but that there's still more work has to be done on the development of these sensors in order to provide the data. Now, is there any further technical development that you can foresee to actually address what Colin is saying, that we don't do sampling just when the ship is in port, but probably throughout the whole performance of the ballast water management system?
if you're regarding to the samplings for the test, I don't think that makers can do much. What I covered and explained about is the improvement of the system itself for being more rugged and performs better, so they can give the credibility, even not doing the detailed sampling test. So everyone is working even harder to find or develop the critical parts and the components, but still takes time. And actually, that I believe that PSC sampling for the training and everything will take some time. But the requirement, IMO requirements already started for the D2 commissioning test. So we'll get a lot of test reports on that. So I believe that we can get more data and see the result from the D2 sampling. That's done by the professional, the laboratories and the institutions, and it's very important to get the information first.
Thank you. And Colin, can get back to you now. When it comes to port control, and you mentioned that Canada, for example, focused on ships that were 3 to 5 years old. Can you expand a little bit of the criteria of why Transport Canada focused on those ships, for example, and you know, what is the benefit of that?
So I'd love to say that we made that decision that we were going to focus on the 3 to 5 year ships. The reality is that it's actually really hard to find these ships that had treatment systems on board, that were planning to use them. Because remember, this work has taken place over the last 3 or 4 years when treatment systems have only just been coming into play. And so it wasn't a choice. Those were the ships that were coming in, that had the time, that could accommodate the scientific testing team. And we saw that we were seeing this pattern of the older treatment systems. I mention it because a lot of the other results that have come into the experience building phase have been the commissioning tests. And in the commissioning test scenario, of course, you need the system to work at commissioning so that you can sign off. So we think that our data set is kind of unique in that respect. And it does raise some questions about whether or not treatment systems will continue to perform with time or whether they will degrade with time. And if they degrade with time, the question will be why. And is it linked to maintenance? Is it linked to crew training? You know, you had that first crew who were freshly trained at commissioning time, but then crew changes naturally occur. You're farther from the delivery point of the treatment system. So there may be in practice challenges with that kind of scenario that will be helpful to identify. And just to connect as well to Mr. Lee and to Mike's comments about the sensors, and I would quite agree that having onboard testing to the D2 standard may be difficult, but we can certainly test, is the chlorination system working, right? Is the UV lamp performing the way it's expected to perform? And this is going to inform whether or not the treatment is working in the end. So we can identify there may be some opportunities to work with the manufacturers to talk about how can we, and the systems do monitor themselves, right? So how can we make use of that information to ensure that the right training has been provided, that the system's being operated correctly, that it's being properly maintained, and we get the best that we can get out of that equipment.
Thank you. Just before I go back to the two of them, and it looks like I'm forgetting about the rest, but no, I'll get to biofouling in a minute, and then at the end we're going to do the crossover between the two instruments. If anyone wants to have pose a question to the panel, please do so. Just interrupt me at any time, and please, we'll bring a microphone, and the intention is not for us to monopolize the conversation up here, but to the panel, no questions to the moderator. I'm just going to highlight that now.
Just one thing to adding to the
Yes.
Colin's last statement, that we and some other makers are already installing the remote service systems, getting the data from the ships. Just for TechROS, we have installed more than 70 vessels, and we can do the pre-analysis for the precautions or everything. So as time goes by, we'll gather more data and provide to the ship owners.
Right, and the last thing for both of you before I move to biofouling is, Mr. Lee, you mentioned this on your presentation twice, and Colin just finished his last intervention with this. With my glasses. Focus on installation, crew training, maintenance, and operation. In your presentation, you highlighted as something that we've been working on, but also something that we still have to work on. What do you think, or you consider, are actions that we can take So they provide tangible results that this is improving, because in my experience, for many years at IMO, these topics continue to be raised over and over and over. So this is free for you to, both of you, to say, what do you think that we need to do to actually change that to the positive, and we stop addressing it so often?
It never ends, and so we have to continue to update and acknowledge and train the ship crews. In early days, still, ship crews are there to touch the system. They are not new to the system. And like an engine, they have been always dealing with the engine and hardwares, but this requires, all the system has the controller and involves the software, hardware, sensors, and many things. If anything goes wrong, he can be responsible. So afraid of doing something, so that's why that we talk to owners to, encourage the ship crews to operate all the time. Actually, the trouble they're showing the vessels, they are the one that operate 24 every time. We get the troubles from there, and somehow we find a way to fix it or upgrade it. So we encourage the ship owners and our ship crews to operate all the time.
Colin?
Yeah, I think that's very important, because we need to identify what is going wrong, right? That's the first step. So we need some data on the key indicators. And Mike, in your presentation, you talked about, for example, TRO sensors. If you don't know how much chlorine is going into the water, then you don't know if you're going to be disinfecting your treatment system, right? It's very simple. You need this TRO meter in order to make sure that you're doing a good job with your equipment. But there may be other areas like that that are relatively easy to verify and have a big effect on the treatment system performance. So I'm coming to your installation, training, maintenance, operation question. Because I think once we know what those data points are, then we can say, the next move is to say, that's what port state control is going to check. It's port state control officer is going to get on board the ship, and he or she is going to have a look at these key things that we know are important for ballast water management systems to operate correctly. And we can write that down in the port state control guidelines. This is what's going to be checked. And if we do that, then you better believe the crew is going to check those things first, right? Because they don't want the port state control officer to come on board and say, hey, your TRO sensor's not working. They want to check this first so they know they're going to be in compliance, right? So, and ultimately, that's what's then going to drive the training. Oh, you've got a new crew coming on board. Do they know how to verify these key things that we need in order for the treatment system to work? So it all starts with identifying what are those key parameters of the system that need to be verified, and then we need to say, well, that's what we're going to start checking for. Then the crew will start to do it. The last piece, though, that's tricky is every treatment system is a bit different. So you need to find things that you can check that don't require the port state control officer to spend 40 minutes reading the operation and maintenance manual to look for these things on this particular brand of treatment system, submodel 2, revision 3, installed in 2002, right? It needs to be a higher level check. So if we can overcome those boundaries, then we can build into the system the pressure to install, operate, and maintain correctly, not from a penalization perspective, but from the perspective of working together with the ships, the manufacturers, the port state control officers to verify those key parameters to make sure the systems are working.
Thank you both for that. I'm going to swiftly move to biofouling, and I'll start with Svein. And on this question, it kind of links as well with the experience that I know you have on ballast water management convention. Now, we are going through the revision. You highlighted the main areas of the revision of the guidelines. But in your experience from Norway's implementation of the current guidelines, that I know that it's been quite a proactive country, how do you see the main areas, the practical areas where we may need to focus for the implementation of the revised guidelines? Because we're talking about risk management, inspections, and what's the other one? I just missed it. It's risk management, inspection, and the cleaning, which of course is very similar to what we've been experiencing on the ballast water management. So from that experience and seeing as you're leading the work, where do you think that we're going when we're going to address these main aspects in the revision of the guidelines?
Thank you very much for a very good question, and I try to be precise and as short as possible in my answer. Now, biofouling is much simpler, but also much complex than ballast water management. Now, if we have gone this far with ballast water management, because we have come a very long way and we have now the implementation, that is more complex for the ship crew, ship owners, than biofouling management will be for the ship owners. They of course will have their biofouling management and the record book, but they will then need to buy services by service providers. So that is much simpler when it comes to the action to be taken, but still it is a complex issue, because when it comes to defining the standards, and then I come to the issue about the IMO member states and the implementation of the guidelines, then it is a much more complex issue, because in addition to, let's say, the straightforward hull areas, you also have the niche areas, and you have a kind of complex situation where how can you identify that you really have a problem, and how can you identify that action should be taken. Now, everything is about maturity. So, although we have known about this problem for quite a long time, member states are quite early in the phase in, let's say, going into this new area of taking action. We now learn what Korea is doing, which is impressive, and we know what New Zealand and Australia has done and California. But I think it is quite early in the real countries all over the world realize that we have to do something. Therefore, I have to compliment the IMO for the glow fouling project. It's really doing a good job. So it is about to have this to be come all through the system in the various authorities, because there will be different authorities involved, the Environmental Authority and the Maritime Agency involved, and having the willingness from the governments to take action and know what action to take. And then I come to the final point: do we have the legal basis to take action? Do we have the legal basis? And there, of course, it comes into going from guidelines to a mandatory framework. I'm sorry for my very long answer, but I hope it was giving some insight into the issue.
No, it's very good, and actually leads very nicely into something that Mr. Shin mentioned during his presentation, and it's you presented how much work the Republic of Korea has been carried out on the review of how to implement the guidelines. But you pointed out at the need for a convention. Now, in your words, it's the guidelines have been in place since 2011, and Korea has carried out several projects in this respect, but no real implementation like New Zealand or California. Is the lack of the legal instrument the limitation, or do you think that the Republic of Korea could have been another country, or maybe a country that is going to implement it before we have an instrument, a mandatory instrument?
Thank you for the question. The awareness of biofouling in Korea is quite recent. We just recently have paid attention to biofouling because we just learned biofouling can have a negative impact on marine environment. Ship owners used to have used cleaning for ships, as I showed in my pictures, in my presentation. They used divers. Divers dislodged, they got rid of biofouling from surface of ships. But there were no regulations and laws in Korea to make sure that a cleaning job is effectively done. And IMO has high interest in biofouling, and New Zealand has this strict law in place. It has strict regulations covering biofouling, and ship owners in Korea, they had some violence of the New Zealand regulations, and that was a wake-up call for ship owners and shipbuilders in Korea. They started to realize the importance of laws and regulations on biofouling. So we just started creating and enacting laws and regulations, but we don't have the basis and evidence that will support the need of a biofouling convention. That is why we are doing this R&D, and we are still trying to find out how much we can go in terms of technical advancement, and that is why the government is leading this R&D efforts. And if we have enough results from the R&D projects, then I'm not a policymaker, then it is the policymaker's role and the lawmaker's role that they will decide which laws and regulations will be effective in managing biofouling. And starting this year, I believe we have enhanced awareness of the biofouling's impact on the marine environment, and the Ministry of Oceans and Fisheries, they have high interest in biofouling as well, so we will see more progress in the future.
Mr. Kim, please. You can expand further.
Yes, actually, you know, it's the glow fouling becoming conventional will take many years. I don't know how long, but it says many years. But including Korea, and there are many partnerships we have in pretty much many places. For example, last week in Hamburg, Porpic, the hull cleaning initiative, the Luna made a presentation about how many countries have a regulation or they're preparing. I saw the map, and it was maybe 10, 20 countries, but in reality, all the countries, I speak of, the business people or IWC people in every country. Every country is preparing something, not as strong as New Zealand or Australia. Every country I speak of, maybe except one or two, they're preparing something for the simpler regulation.
It's good to know that the awareness is increasing out there. Sachin talked about hope, and he showed us a very nice last slide, and of course led very nicely into all the technical developments and of course the robot that you brought us here. Do you see the technology being developed in time for whenever we had a mandatory instrument, and I'm sorry for saying it, but not facing the same situation that we have with the Ballast Water Management Convention that, I'm sorry to say, we kind of got a little bit caught up, and suppose it's part of it. It happened, didn't it?
Okay. I'll be very honest on this thing, on your question. In terms of technology, biofouling is, from my point of view, is very much far ready, more ready than I'm sorry about that. They are ready. For example, during the presentation, the whole, for example, last week in Hamburg, there was some researcher from Australia, and they told us this new technology or method that by divers can really, really clean the niche area perfectly. Well, using the ROV technology or the capturing technology is getting very, very, mature. And it is possible to clean the hulls also. And for the niche area, interestingly, there are going to be a lot of new divers coming into this area because what they require, when I first heard that in Singapore, I thought it doesn't make sense, but when I talked to this Australian, researcher, and it makes sense because they're pouring hot water into the sea chest. Yeah, it is, like for 3 hours, like 90 degree. So basically, if you cannot reach, it is like, for example, the places between the propeller shaft and the rope guard, you cannot put your hand in there. But if you really stay in there, you see, green mussels or something, which is an invasive species. And what they're doing is right now, not many in Korea, but in Singapore, they're pouring hot water and chemicals into that niche, hard-to-reach area, and they're actually killing them. So using like a handheld, and also, a company called Subsea Global, and you have this propeller polishing tool. You can actually polish and capture at the same time and filter. So there are technology perfectly fit for maintaining the hull, but the problem is the capacity. Well, I want to say this. I'm sorry about saying too much, but if you do make the regulation, yeah, I mean the shipping company will pay more actually because we're not ready in terms of capacity. But you don't need to be on the side of the shipping industry. I mean, really, I mean, shouldn't we all protect the environment more? If the price goes up, the capacity will grow faster, much faster. And what I'm saying is, I mean, it could be a very small amount increasing for the shipping company, and they're making a lot of money, aren't they?
Thank you. And anyone, whenever you want to jump in here as well, please do so, because the couple of questions I'm going to pose are a little bit more open. And I'll try to lead with Spani on this, because it seems like the technology is going to be there. Of course, there will be cost implications. And you talked about capture, which is going to be quite important. Of course, how we dispose that in a sustainable manner as well. With everything that keeps coming on the environmental regulations, our governments, our ship owners, also ready for additional impacts when it comes to new measures in relation to biofouling?
Now, again, thank you very much for a very precise and good question, and I tried to be as short as possible in my answer. Now, I think what we observe on this topic is similar to what we have observed on other topics, meaning that when we are going from guidelines, meaning recommendation, the recommendation on the method to use in order to prevent and deal with the problem is more vague and not as precise as when we are going into mandatory requirements, because then it is about you need to comply, and we need to enforce, and we need then to have much more precise regulation. And then I come to technology, because the methods we need to use needs to deal with the problem. And we cannot now go into the failure of having a too long process to develop, let's say, standards which are too weak, meaning that actually those who have the good systems, the good technologies, have not the competitive advantage that they should have got compared to the cheap one. And that is a dilemma, and that is also a part of the negotiation at the IMO. And then we come into the same sort of problem which we have on the ballast water. We need to have the testing and approval, and we need then to enforce, are those systems really performing as they should have been performing? Now, based on what I have seen on the many IMO framework, I think we are in a quite good position when it comes to biofouling. I think the technology providers can resolve all these problems. I think that we can develop a proper standard. I think we can have a type approval system, and I think we can have a robust enforcement system. Everything is possible if there is willingness for the member states to establish such a framework. I think the industry is ready to deliver that service to the ship owners. And I think they are willing to pay as well, because, as I said, there are also savings. You save fuels, you save money. Thank you.
That's very good. It's how you link all the different environmental measures of the organization and how one can actually supplement another one. And this is a bit of an open question coming from this, because it sounds like we're in a better path when it comes to the biofouling work right now. The technology the way that we are gathering experience, moving to a revised guidelines and in the future possibly a mandatory instrument. With ballast water, a lot of emphasis has been on the variables of the environment and how they affect the system. Do you think that it will be the same case even with technology for biofouling? Is there anything that we can learn from one and the other, or one can learn a little bit more from the other? Because the challenges of the environment are always going to be there, and I can see that even with biofouling, the way that some ports will react to ships coming in this respect. So I'll start. Sveinung, why don't you kick it off?
I think we can learn a lot from the Ballast Water Management Convention. Okay, some say that we have done some failures on that convention. I would say some small failures, I would say, because this was totally new grounds for the IMO. And we are in the process, let's say, fixing those failures. And we have to remember that all the annexes of the MARPOL Convention have been revised, meaning that it's a first generation and a second generation of the mandatory instruments. So I think one of the most important things we have learned from the Ballast Water Management Convention is that the system of type approval and testing needs to function. So there we went from guidelines into a code in the ballast water, and I think when we come into the next stage of the biofouling, first we need to revise the guidelines, but when we come into the next stage, we can learn a lot for the ballast water management.
Colin?
Yeah, and Sveinung, I'm going to ask you to step in and correct me if I'm wrong on this, in terms of the biofouling, the discussions around the biofouling convention. But a lot of these conventions have some built-in tensions, and it seems to me that on the biofouling side, we want to be in a situation where we have clean ships. And I think a lot of countries are going to be very quick to say, well, we only want to receive clean ships. But these ships have to be cleaned somewhere. And so we need to make sure that when we're putting in a regime, and we've been talking today about regimes that have mandatory components, that we're actually positioning the industry to be in compliance. And that means that, okay, if Canada wants to have ships coming in that are clean, what are we doing to contribute to the need for in-water cleaning of these ships? And if we're uncomfortable with cleaning, macrofouling off of these ships that may pose a high risk, well, where is the ship supposed to do that work? And the right time to be thinking about these issues, it seems to me, is now when we're developing the guidelines and we can be talking about, okay, well, what are we going to be comfortable cleaning, let's say, in Canada? And does that influence what we're encouraging ships to do in order to deal with their problems early enough? On ballast water, we also have some tensions, and they're a little bit different, but that one, I think, as you say, if we type approve this technology and we know it works, then are people going to accept its use in their waters in order to keep the ships on the go?
That's quite a valid point, because the responsibility is not always on the ship. From the Republic of Korea, is there anything with all the research, with the projects, is there anything that has been looked at to directly see what is the part from the port, from the government into facilitating this process for the ships?
So I'd like to add a few words to Colin's remarks and then answer the moderator's question. Yes, IMO has come up with a guideline. This is not mandatory, though. Biofouling, when we do inspection on biofouling of ships entering our waters, and we found that, let's assume that we find macrofouling, and the cleaning should be done somewhere. It is not right that we do the cleaning in countries or waters where that do not offer any laws and regulations, and the impact will be done not only the country, but ships and other countries that have ships that enter that water. So I think the primary goal of this guideline for biofouling is we have to designate a water or a port where the cleaning should be done. When the cleaning is done, there could be bioproducts, and we should have infrastructure, and we should have systems that can get rid of the bioproducts. So we need to have this system and devices and infrastructure at every port around the world. That is ideal. In Korea, we are doing this R&D project. Under this R&D project, we are looking, let's say we are cleaning biofouling at a certain port, and we are trying to find out how much cleaning can be done at that specific port. We are trying to find out the capacity. So we want to make a plan that the cleaning, this much of a cleaning can be done at this specific port, and this should be managed by the government or government agency. There should be someone in charge. Let's say this port can clean biofouling about only 5 ships. Then we will make sure that the 5 ships a day can be cleaned in that port. Regarding conventions and guidelines of the IMO for effective implementation of the guideline and a potential convention at the IMO proposed by IMO, we need to come up with a specific table or list that describes, okay, this much should be cleaned to make sure we don't make negative impact on the environment. Once we have that clear line or threshold, we can make sure implementation of a guideline and even a potential convention. But that requires a consensus first. Without consensus, we won't have effective implementation.
Consensus and effective implementation is something that we know very well at IMO. Spiner knows about this. I think we are running out of time right now, and I can spend the whole day speaking to these very, very nice and knowledgeable colleagues. From each of you, if you want a quick takeaway from the experience that you have today on the exchange of information on these 2 very similar topics, what would be a quick message that you sent out there to the IMO, to the industry, or to the countries in this thing?
Yeah, I mean, it's like yes, for the I mean the new regulations for this guideline to become a convention. I think we always we have to take care of the business too. But it's from my point of view, from not a researcher, maybe from as a father, I think we all see this. Like biofouling is not only about the invasive species, it's about GHG too. Because according to the study in 2020 by IMO, the ships are responsible for 2.8% of the all GHG of the world. And another study by IMO, funded by GIA, says 30 to 50% of the GHG is increased by biofouling. So hull cleaning or cleaning can reduce the GHG by 1%. It's very impeccable thing, and we all see in like very recent years we see these crazy climate change, scary ones like we haven't seen in 100 years or never seen before, and the change is happening, and I think I'm afraid that we're already pretty much late. And sorry about the shipping companies, but we have to really make this happen fast. That's my point. I mean, that's my thing that I really wanted to say.
Thank you. Thank you very much to all of you. I think we are out of time now. Is that correct? You don't have a microphone. We took all the microphone away. I think we're running into your lunch time. Thank you, everybody. It's very clear that we have learned a lot from the ballast water management, that we're moving in the right direction with both ballast water and biofouling. And of course, there's more regulations coming up. Noise pollution, it's coming, and I'm sure that this is going to be another topic that in the future we'll be discussing in line with ballast water and biofouling. So thank you for your attention, and I think they have been great.
Thank you very much for that lively discussion. I also wish we had more time, but maybe you can continue your discussion over lunch. And speaking of which, we're now going to have a lunch break, but before that, let's give our panel of experts and moderator another huge round of applause. And you may return to your seats now. Thank you very much. All right, as I said, we're now going to have a lunch break, and just like yesterday, you may remain in your seats and lunch will be served at your table. And then let's reconvene at 2 p.m. for our session 4, which is titled that is Maritime Autonomous Surface Ships. So I'll see you back here at 2 p.m. Thank you.